All right, so as we get started here, if you take a look real quickly, I think there's two examples on this page for us to go over. One of the differences in this section specifically, unlike the rest, is the fact that you're going to get a full continuous wave. So if you look at examples 1 and 2 in your notes, do you notice that it's not like a single period of a wave? Yes, we're in lesson 3. Yeah. Okay. So step 1 in approaching these problems are that we need to choose correctly a part of the wave that represents one period. Now, this is where there is some flexibility, and some of you will see this differently. So I'm going to skip here to example 1. As you look here, what pops out to you? Do you see first a sine wave or a cosine wave? Most of you will see cosine. If you see sine, that's okay. Your answer can be sine. But when you choose that, it's going to change some of the other letters in the equation itself, which means there's multiple solutions. Okay? So this is a little bit harder to have an answer key for. My first suggestion is this. Choose cosine, for example, and then sketch that part of the graph. So we're going to start at the mountain. We're going to go to the bottom, and we're going to come down. So this is one complete period of cosine. Right. Now notice there's a formula there that had sine in it. Some people always like to use sine. It's up to you. Okay. So my first thing is that when I'm writing my equation, my y equals, I know that I'm going to deal with cosine as my ratio. Now, if you look along the axis at the bottom, note that you are dealing with all degrees. Sorry. Which means that I'm going to be dealing with a theta. Okay, so that's another part that you can get by looking at the graph. Notice this goes down to -2. Watch your units. These are not single increments. So going all the way up, it's going to be at 10. If I go from -2 to 10, that's a total distance of 12. Where would the center of the wave be located at? What value? It would actually be at 4. 6 units away. All right? That 4 is always going to be the +4 at the end, no matter what the function is. The center line is always going to correspond to the value at the end. To me, it looks like regular old cosine, which means I'm going to have a positive out front. Do I have an amplitude change? And if so, what is the amplitude? Nope, not 10. Count from the center line to the mountains or valleys. How far is this? 6 units, so I'm going to have a 6 in front of my cosine graph. Now, if we're careful, do you notice that cosine shifted left 60 degrees? Yes? It went this way, 60 degrees. So in my parentheses over here, I'm going to move this a little bit further apart here. In my parentheses, I'm going to have theta plus 60. Because left-right shifts are opposite. And now the hardest part, and this is the part that I would recommend going back, studying, reviewing, especially before the test, is determining the period. Remember, the period is going to be the coefficient of the quantity. What is the normal period of cosine? How wide is it normally? 2 pi, or in degrees, 360. So my period normally is 360 degrees. I'm going to divide it by A. So we're going to pretend that that's the A value. I'm going to solve a quick equation here. That is going to equal, this is -60 all the way up to 660. How many total degrees is that? From -60 to 660. Total distance. 720. So that is going to equal 720 degrees. That takes the total length from the start of the cosine until the end of the cosine. Is anyone confused why I wrote 720? how I would calculate it. Okay, it starts at -60 and it goes to 660. So what is this distance? 720. So it's the total distance. If you want a formula, you always take the highest one, subtract the lowest. So 660 minus 60 for linear distance subtraction. Okay? If I solve this equation, I get 360 over 720 is equal to A. A is equal to 1/2, which means what goes in here is going to be 1/2. Yep.
Since you feel rough, do you usually guess everything between 1 and 0 and 1 to 20?
It's not really a guess. We're not going to give you ones that you can't easily look at and calculate. So that's why we use nice numbers like that. Same thing with this calculation. This is going to come out to a nice fraction. It's going to come out to a nice whole number or something. Okay. Notice in my last step, I then rewrote by distributing the 1/2. Everything else stayed the same. All right, let's do one more. Example 2. And just for the fun of it, in example 2, let's pick sine this time. Okay. So I'm going to look at this picture, and I'm going to say, all right, I'm going to choose sine. So I'm going to start here, I'm going to go up, I'm going to come down, and I'm going to come around. Center line is here at 12. Goes up to 16, goes down to 8. Key numbers, key points. I'm going to turn that off your face as well. All right, so again, we've got our y equals. Please don't forget that. We're going to talk about sine. We know what the end is going to be over here. It's going to be a plus 12. Any questions on that part of it? X or theta? X or thetas? Which variable am I going to use? X is because I have values that are in radians. Okay, so I'm going to be dealing with X. All right, so now what happened to my sine graph? How did it shift? Well, we went this way, didn't we, to the left again? We went to the left, pi over 6. So in here, I'm going to have an x plus pi over 6. Amplitude is 4, and it's a positive. It's regular old sine. So the only thing I have to figure out is A, period change. Sine normally has a period of 2 pi. We're going to start here at, looks like, negative pi over 6. And then we're going to go all the way over here, which looks like, what, 5 pi over 6? For the most part, you can kind of assume like these are the same space distances. They're not going to be weird or off. They're very straightforward. So notice that this shifted from here, pi over 6. It's going to also shift from pi over 6. 6 over 6 minus 1 over 6 is 5 over 6. Back to being able to do fractions today. So what is the total period length? From here to here, the total is pi. So that's what I'm going to set equal here. So I get 2 pi divided by pi is equal to A. A is equal to 2. And I'm done. Yes. What's that? What? Are you good with 5 pi over 6? Okay, so at the bottom, are you okay with this clearly being moved back pi over 6. Okay, so from a pure distance perspective, let's go with green. This line has a distance of pi over 6 because I moved it left pi over 6, right? So now if I come over here to pi, which is what is clearly marked there, and I bring down this end key point, do you notice how this is the same size? Which means that the location of this ending point is going to be pi over 6 away from pi, which is 5 pi over 6. Okay, so when I said that this shifted left pi over 6, my denominator is 6. So how many parts do I have to get to 1 pi? Just in general, from 0 to pi, the denominator is 6. How many pieces are there? There are 6. 1, 2, 3, 4, 5, 6 gives you 6 over 6. So if I'm moving this pi over 6 here, and I'm shifting it here, that takes me to 5 pi over 6. Yeah? Okay. So the key here is that if this was shifted, for instance, if this was shifted pi over 9, I'll just make up a random one, right? Pi over 9, this corresponding distance would put me at 8 pi over 9 when shifted over. Yes?
So, for the final answer,
You're going to see answers in both forms. If it was a test, I would accept the purple. Okay, if it was multiple choice, it might be red. If you're looking at an answer key, make sure you understand that red and purple are the same thing.